Hi, welcome to the class. Today we will start chapter number 2, that is work energy power. In this chapter, first we will define work, then we will calculate work, and the same thing we will be doing for power and energy. Then we will be discussing about types of mechanical energy, and at last we will discuss about conservation of energy. So let's start the chapter. So work. What is work? So work is defined whenever a force is being applied on a body, on an object, and the body does some displacement. That is what we call work. So this is how the work is defined in physics. A force should be applied and the body should displace from its position. And displacement means change in position of the body after applying the force. The body cannot stay at the same position after applying the force. It has to change its position after applying the force. Now, work is a scalar quantity. So what do we mean by scalar quantities? That is that scalar quantities do not have any direction. They just have magnitude. Magnitude means size. They just have a number. We can measure them and they have their magnitude, their size. They do not have any kind of direction. What is the SI unit of work? So SI unit of work is joule and its symbol is capital J. So you have to write joule starting with small j and then the symbol has to be capital J. CGS unit of work is erg, ERG, erg. So this is how we define work, and this is the SI unit and CGS unit of work. So next we'll understand how to calculate the work. So for calculation of work we have two cases. The first case in which a force is being applied and the body does displacement in the direction of the force. So whenever a force is being applied and the body does displacement in the direction of the force, in that case the product of force and displacement will give you the work. So work can be calculated by multiplying force and displacement. So W is equals to F into S. What is W? W is work done, F is force which is being applied, and S is the displacement. That is change in position of the object after applying a force. In the second case, what happens is a force is being applied and the displacement is being done in some other direction. That is, a force is being applied in some other direction and the displacement is being done in some other direction. So what could be the example? Example could be a child applying a force on a toy car using a thread. So the car is being tied with a thread and the child is applying a force in this direction and the car is doing displacement in this direction. So in this case the force is being applied in this direction, displacement takes place in this direction. So there is an angle which is created between force and displacement, and that angle is theta. So in this case the work will be calculated using W is equals to Fs cos theta. So this cosine is a trigonometrical ratio and theta is the angle between force and displacement. So theta is the angle between force and displacement, and W is equals to Fs cos theta. So if you know the force, if you know the displacement, you know the theta. So you applying this formula, you can easily calculate work. So this is how work can be calculated for two different cases. So as I told you, work can be calculated with the help of force and displacement. That is, when force is being multiplied by displacement, work can be calculated. So W is equals to F into S. W is work, F is force, and S is displacement. SI unit of force is Newton and SI unit of displacement is meter. So if you multiply these two, it will be Newton meter. And this Newton meter is known as joule. That is the SI unit of work. Now, SI unit of force is diam and CGS unit of force is diam and CGS unit of displacement is centimeter. So if you multiply diam by centimeter, it will become diam centimeter, which is the CGS unit of work. Now we have special cases for work. So what are the special cases for work? Basically work can be categorized into three types. So first is positive work, second is zero work, and third is negative work. So when positive work will be done, as I told you, work can be calculated by two ways. First was work is equals to force into displacement. In this case, the force and displacement takes place in the same direction. But if an angle is being created between force and displacement, so the formula for work will be Fs cos theta. So in this case, now the type of work which will take place, that is positive work, zero work or negative work, it depends upon this theta angle. Theta is the angle between force and displacement. So what happens is, for positive work, the force and displacement takes place in the same direction. So it becomes this case only. So in this case, cos theta, that is theta angle is 0. Why this angle is 0? Because the force is applied on an object and the object moves in the direction of the force which is applied. So that will be positive work. So in this case, theta will be 0, cos 0 is 1, and if cos 0 is 1, then work will be Fs, F into S. So it becomes this case only. So this is the positive work. So what are the examples of positive work? So examples of positive work, a ball is being kicked and the force is being applied and the ball will roll down in the direction of the force itself. If you lift up an object, what will happen? You are applying a force in the upward direction and the body does displacement in the same direction, that is in the upward direction. So these two are the examples of the positive work. As you can see, the displacement takes place in the direction of the force itself. Now coming to the second case, that is zero work. So zero work, in this case the angle between the force and displacement is 90 degree. So the force and displacement are perpendicular to each other. So in this case, cos 90 will be 0, and when cos 90 will be 0, therefore this term will be 0, cos 90 will be 0, and 0 multiplied by F into S will again 0. So in this case the work done will be 0. So what are the examples of this kind of work? This kind of work, examples of this kind of work, a wall is being pushed by somebody. So when a wall is being pushed by somebody, what's happening here? The angle between the force and the displacement is 0. Actually there is no displacement. So no displacement in the wall, and that makes 0 work. So that could be one of the examples of zero work. But if you are looking at the examples where theta is 90, that could be somebody lifting an object and a coolie lifting an object on his head and then walking. So what's happening in that case? Suppose this is the object which is being lifted by a coolie and the coolie is doing a displacement in this direction. So S, that is the displacement of the object, and the coolie is taking place in this direction as the object is kept on the head of the coolie. So the weight of the object, that is the force of gravity which is acting on the object, will be downwards, W, it's downwards like this, and displacement is taking in this direction. So as you can see, the angle between this force, which is the force of gravity, and displacement is 90 degree, and if theta is 90, cos 90 will be 0, and therefore the work will be 0. So this is one example. One important example here to discuss about zero work where theta is 90 is the motion in a circular path. So how does it work? So basically, as we know that we require a centripetal force which acts towards the center if an object is moving in a circular path. So you know the velocity, the component of the velocity will always be tangential, in the tangential direction. That is, there is displacement of the object. If at any point of time you cut this thread, the displacement of the object will take place along the tangential direction. So this is the displacement of the object along the tangential direction, which is also the direction of the velocity. So as you can see, this radius and this tangent, they both are perpendicular to each other. So in this case you can see that angle between force and displacement, is 90 degree, theta is 90 degree, cos 90 will be 0 and work done will be 0. So it means that whenever an object moves in a circular path, let it be earth revolving around the sun, or let it be electron moving around nucleus, in that case the work done is 0. Now coming to negative work, so when the negative work will take place. Now this is important to understand and very interesting case to discuss, as in this case theta will be 180 degree. So when theta will be 180 degree, when force is being applied in this direction but the displacement takes place in the opposite direction. So when force is being applied in this direction and the displacement takes place in this direction, in that case theta will be 180 degree and cos 180 will be -1, and if cos 180 is -1, so force multiplied by displacement multiplied by -1, as theta is 180, so work done will be minus F into S. So the work will be negative. Now, how does this work? You are applying a force on an object and the object is moving in the forward direction. Now there is a force of friction which is acting in the opposite direction. So the work done by the force of friction will be negative. Okay, so in this case you have to keep in one thing in mind, that the force which you are applying to do the work will always be a positive work, but the force which is being applied externally, that is the resistive forces. Now what are the resistive forces? Friction is a resistive force, gravity is a resistive force if the object is moving in the upward direction. So suppose I throw the object in the upward direction, the force applied by me is in the upward direction, displacement will take place in the upward direction, but there is a force of gravity which is pulling down this object. So work done by the force of gravity will be negative. Why it will be negative? Because the marker is going in the upward direction and the force is applied in the downward direction. I am talking about the force of gravity. So the external force or the resistive forces always do this negative work, because in that case the force applied is always to oppose the motion of the object. So this is how gravity and friction does the negative work. So in that case theta is 180 degree and cos 180 is -1, so work will be minus F into S. So these are the special cases for work where we discussed about the positive work, zero work and negative work. So it is very important for us to understand the examples of these, and we should also know the angle which is there between force and displacement.